Hello, welcome to the MetaGenome project. My name is Jacob, and this is a short demo to highlight the mechanisms that we use to capture metamaterial data and how you can interact with the website. So the first thing to do is to log in or sign up. If you're new, you can request an account and it'll be validated by one of our administrators. I've already made an account, so I'll just log in. There we are. So for submission, we want to go up to data curation here. So once you're logged in, data curation. And we're going to click on Schema 31, which encapsulates a wide range of properties and fields to capture as much information as possible for mechanical metamaterials. And hopefully everyone is able to submit to this with the data that they have. So we're going to select a template, select this template, sorry, and we're going to create a new document. So in the first instance, let's say that we're uploading a base material that is made from nylon 12. So we'll say nylon 12 base mat. Let's go. So now we'll start editing. And we're met with a range of fields. So these are devised by the schema, and the way in which you interact with them is hopefully covered within as placeholders or is as obvious as possible. So here we have a drop-down menu. Here's a field for text entry, etc., etc. So in the first instance, we ask that people understand that this data is contributed under the Creative Commons license, and we go for yes. And are we updating a previous version? No. Then we go on to include the reference information to the publication that this is derived from. So this DOI, publication DOI, will require a URL type string. So you can have www.url.com. Silly, but there it is. These require string fields, so one A, and then just have B here, and the title. This is a string field, and then we get onto integer fields like volume, issue, page, etc., etc. And email is also somewhat specialized. So now we can see we're being asked for the mechanical convention used throughout. So we hit the little plus icon here to open these drop-down menus. We're going to stay on engineering strain, and now we get to the opportunity to put in the bulk of the data pertaining to our submission. So we'll go for a bulk material, as this is a base material submission, and we can describe the name, a little bit about the classification. If it's different, we can kind of cover it there. We can upload the chemical composition, so highlight carbon, phosphorus, and nitrogen. You can describe the quantity of these elements. So let's say we've got 12, 1, 2, just as dummy data. Now we've described something about the chemical composition. We're asked to provide information on the bulk density, the units there, the von Mises stress, and the von Mises stress unit. So if you're able to provide these, then please do. These are optional fields as they are only they're not requesting data by default, but if you can hit the plus and put in data, again, please do. So now we go on to the directional sensitivity. Now these fork a relatively large amount. So for this demonstration, again, just to for how to interact with the thing, we're just going to go for isotropic, keep it nice and simple. So we have like the request for the tensile modulus data, so we can just start here. We're asking for the testing conditions, so the cross-sectional shape, the width of the cross-section, the sample used, and the units it's measured in, and so on. We can actually then provide the value of the tensile modulus and the units associated with it, and we also request some information on the conditions, so temperature, humidity, etc. Now, we also do this for compressive modulus, tensile Poisson's ratio, all the way down to the twist data, so that they follow the same trend. So if I click compressive modulus, it asks for the test conditions, test conditions, the value and the units, and testing conditions, so temperature, etc. So these are the same. Then we also have different fields for stress strain data and axial versus transverse strain data. So if we go in here, we first ask for the units, so MPa, megapascals. So the mechanism for this is we enable people to upload stress versus strain data as .xls forms. So I will demonstrate that right now. So first we just provide this string to validate that we're using the right file type. Then we can, so I've prepared one earlier, and we'll just show you what it looks like. So we click here, base material, and it's digested my Excel form, which contained 2 columns with blank top rows, which is what we ask for, just to try and keep things consistent within the database. So if you pay attention up here, this will describe how the Excel form should be formatted. And in this case, it is with strain in column A and stress in column B, which is what we have here. We then ask for confirmation of this. Yes, yes. And these are the same format as we've just seen. So if we go axial versus transverse, we have the same thing. We're asking for the loading axis and the transverse axis. So these are X, Y, Z. And you can then upload another Excel file for this. In addition, if you have multiple plots and data points for your axial transverse data, you can hit this plus and another field, the identical set of fields will appear below, and they can all be stored under one schema. So I'd like to demonstrate the validation procedure now. So I'm just going to minimize as much as I can to make this quite a small submission, just to show you what it looks like when you go on to validate. So I'll put in some values, 1, 2, 3. That's okay. This might kick back an error from a validation, but that it's invalid, but we will see. Material name, nylon. That's fine. So we can just fill this out for now. Title 1, 1, 1, 1, 1. That's a journal. URL. So url.com. J email email.com. So now if we go on to validate, this should pass. Yes. Okay. So we can go on to review the submission, and we can see it's put this into an XML type form. So this is how we're storing things. This gives you the opportunity to check that everything is correct. And it looks, this is dummy data, so it's obviously not correct, but we'll sort that out after. So if we save that to repo, okay, it's been saved. Now we go over to my records, and here it is, nylon 12 base mat. So we can inspect this, and it's the same, but now we have generated a PID. So this is a unique identifier for this submission, which is here. So this is a link that will send you directly to this submission. So this is important for now. I will copy and close, as we can do something quite interesting in that we can link the base materials to the metamaterial submission. So if we go back to this, to the data curation, and we fill out another template. So we're going to say nylon 12 meta. So this would be us filling out our metamaterial data. Oops, not unique, sorry. Metamat. There we are. So it's the same form, exactly the same principle. Fill out your publication data, stress convention, and now we're going to go into metamaterial. Things are slightly different here. So we're first asking, is it numerical experimental? The metamaterial family, how many base components is this made from? And we also have the opportunity for people to upload topology files. So I have step files, so I'm going to upload a step file. I'm going to upload a local, so nylon step, up save. It just takes a second. So this generates a unique PID, which is a URL to enable you to download this step file that you've uploaded, or provide that to someone else if you give the correct permissions in the workspaces. within the metagenome. And yeah, so this unique PID system is akin to DOIs. However, it's only unique to the metagenome. So this is where we're kind of thinking about assigning topologies, components within topologies. So if a topology is split into multiple parts, you can upload individual parts of your topology file and assign the base material to each part, and then they can be reconstructed in post-processing. So like we have, we know that this is going to be made out of nylon, and we can provide the PID, which is what we had for the initial the copy and paste I did earlier, and this links it all together. So it's a way of intercommunication within the database. We also have the opportunity for people to upload an image file if they have those available. And yeah, if you have a foam, there are ways for you to describe your auxetic foam parameters. And if you have custom parameters, you can fill them out here. So this has covered most of the key features within the MetaGenome project, and hopefully you're able to interact with it well enough. If you have any questions, please do get in touch with anyone on the team, and happy submitting. Thank you.